Okay, so what we have here is just kind of a couple of lines, right? This line here could be called AB or AE, okay? This line over here could be called what? CB or CD. You see the points there on that line. And they meet here at point B. And what I've done is I've just basically used my angle measurement tool and measured these angles. So this is measure of angle CBA. So this angle here, let me get my pencil out. So that's this angle here, which I might call angle, I'm just going to refer to it as A, okay? So basically CBA measures 80.23 degrees. Now notice when I name the angle that the vertex of the angle, that's the point right there, right? It has to be the middle letter in the three letters named. So this is CBA, or it could be ABC. But it's not angle B. There's too many angles involved with B to be just calling it angle B. And you know, obviously the A and the C indicate the rays that make up this angle, right? And B, the vertex or the initial point of those two rays, goes in the middle. Okay, so anyway, angle A measures 80.23 degrees. Over here, I'm going to name this one just, you know, for shorthand, I'm going to name B here. And we have, this is angle DBE or EBD. Over here, we have angle, we'll call angle C for shorthand, but it's actually angle ABD or angle DBA, right? And then over here, the last angle over here that's formed is angle D. And we'll call it angle D, but formally it is called CBE or EBC. Now I've got the measurements there, and you can see that the measurements are all the same. So this is just a common occurrence in the world that we live in, where one line crosses another line. You're always going to have a set of four angles that are formed when those two cross, okay? And there's a special name we give to these pairs of angles. I want you to look at it really closely. If you see this angle over here and this one here, A and B, they have exactly the same measure, and these two have exactly the same measure. So these angles that are formed at the crossing of lines, the ones opposite each other are actually, you know, they have a name, and they're called vertical angles. So vertical angles, the thing you notice about them is that they have the same measure. Is that always true, or is it just the way I set it up? Well, we can see here if I move, right, change, like, you know, the angles here, you can see that they remain the same. It doesn't matter what happens. The vertical angles always measure the same. So that's what our observation is. But actually, what we're supposed to be able to do here is we're supposed to be able to write a proof about that. We're supposed to be able to prove that vertical angles will always measure the same. So I want you to think about this. Now, what we know is that two angles, right, whose non-adjacent sides form opposite rays are called a linear pair. So that'd be like angle A and D is a linear pair because angle ABC, right, and angle CBE, these are adjacent angles. They share ray. BC is a adjacent side. It's a similar side for both those angle pairs. And their non-adjacent sides, BA and BE, are opposite rays. So that means that together they are called a linear pair. That's the name that we give them. And what it means is that their degrees would always add up to 180 degrees. So if I take 90.41 plus 89.59, that's going to equal 180 degrees. It doesn't matter how I change this. If I stop at any point and add those two numbers together, it's going to equal 180 degrees. And that's because if you think about it, this line would divide a circle, right? The circle has 360 degrees, and half of it would be on one side of the circle, half would be on the other. So it's always going to be 180 degrees. So this is really important to understand. A and D equal 180 degrees. Well, the same could be said about these two angles, D and B, right? They're always going to equal 180 degrees. They are also a linear pair, right? They're non-adjacent sides, so that's side BC here of angle D and side BD of this angle over here B. So these two have their non-adjacent sides, right, are opposite rays again. So they are a linear pair, And then there is a thing called the linear pair postulate, which means that all linear pairs are going to be supplementary. And so if you add their measures, they're going to equal 180 degrees. So, well, how does that kind of help us out? Well, let's think about this. I'm going to put some text over here. And, well, let's see how this will work. If I said angle A plus angle B equals 180 degrees, we could agree that's true. And the reason that's true is because they are a linear pair by definition, right? And the linear pair postulate tells says all linear pair are supplementary, right? And supplementary means that they're sum to 180 by definition, right? So that's basically the logic behind the claim that A and B equals 180 degrees, right? So I'll put that right there for you. Think about that for a minute. A plus B is a linear pair by definition. Why? Because it's not their non-adjacent sides are opposite rays. And the linear pair postulate says that all linear pairs are supplementary, right? And supplementary means that their angle measures sum to 180 degrees by the definition of supplementary angles, okay? So we can conclude that A plus B, bad. This is not good. It's not A plus B, it's A plus D. Sorry about that. We better catch that quick. A plus D are supplementary, right? A and D together. Woo, that was a close one. Bet you were sitting there watching saying, what's wrong with Mr. T? Well, okay. Now, let's use the same exact logic and conclude that D plus B is equal to 180. So let's put that down here, right? We would say D plus B equals 180. So we're talking about angle D and angle B. And how do we know that D plus B equals 180? I better put in here by the same logic, okay? We're not going to repeat all of that, but basically by the same logic we know that if we take A plus D, if we've proven that A and D together are equal to 180, and 180 means 180 degrees, then we can use the same logic and conclude that D and B are equal to 180 degrees as well. All right. So now, since these are both equal to 180 degrees, there is a property that says if two things are equal to each other, or equal to the same thing, then they're equal to each other. That's called the transitive. It's like saying, you know, if I have $50 and you have $50, then we both have the same amount, right? That's the transitive property, basically. So, so we're going to go ahead and put this in here. Oh boy, I'll get my text tool back. Where'd it go? There it is. Okay, so that means since A plus D equals, D equals 180, and that is also equal to D plus B, there we have our statement. There we would say then A plus D equals D plus B, right? So let's just make sure we understand what that logic says. Since they both equal 180, they must be equal to each other, right? Okay, let's do a little more in here. Now what can we do next? Well, we can say that if I have A plus D and I take away D, that must be equal to D plus B take away D, right? And that really is by the subtraction property of equality. So if you have something that's equal, right? If you have something that's equal and then you subtract the same thing from both sides, then what you have is you have, you still remain equal because you just took away the same thing from both sides. So that's what the subtraction property of equality says. So we make that little statement there, right? And then all we're going to do now is our final step is going to be to simply say, we're going to simplify, and then we're just left with A equals B, right? Okay, and all we did was we simplified. Okay, So let's see how that would look. If we use a little algebra here, if we had D and took away D, we'd be left with just A. That's this side. If we had D and B on one side, but we took away the D, those guys would go away and you'd just be left with B on one side. So you end up with A equals B. That's our simplified final statement. Well, A and B are vertical angles. So this is the logical proof that tells us no matter what, even when we move our angles or the line, the angles that are formed, the opposite angles are always going to be equal to each other. So your proof that vertical angles are always equal to each other is right here. Your job to understand it, be able to articulate it, and maybe make a move note where you explain it kind of like I did. Okay, good luck.